Good day all, and welcome once again to my channel. It's been a while that I've posted in this channel, but now I'm back. This time I'm going to be focusing more on the O-level series, talking about JAM, the forthcoming JAM and the forthcoming WAEC. So for those students that are preparing to writing WAEC 2024 and JAM 2024, and you know you are a science student, this channel is for you. Make sure you stay glued to this channel, for especially those of you that are writing JAM 2024. Now I'm going to be running through a series of classes in this channel, and it's with my hope that as I run through the series, you would understand virtually many things in the course of the lessons. Alright, so now I'm going to be focusing on the topic today, and the topic is Introduction to Hydrocarbons, talking about chemistry. Because this channel is not just only for chemistry, we still have biology as well as mathematics, even physics. So the thing is, I'm only focusing on chemistry for today. Please pay attention as I run through the series of this introduction to hydrocarbons, because this topic is a very, very important topic that JAM usually bring questions. Alright? So, looking at the word hydrocarbons, because I'm not going to be wasting much time on this topic. Now, when we say hydrocarbons, what should come to your mind is that this is actually a compound. Yeah, they are compounds. Because looking at the initials of chemistry, talking about matter, we have the fundamentals of matter, the concepts that are associated with matter. What we talk about, the states of matter, the classes of matter, and particulate nature of matter. I've explained all these in my previous videos. You can actually check them out. Now, looking at the classes of matter, we have three fundamental classes of matter, which includes elements, compounds, and mixtures. Now, this happens to be a compound, that's hydrocarbon, but hydrocarbons are compounds. You understand? Now, these are simply compounds. From the name hydrocarbons, they are actually compounds that are made up of two elements. And what are the two elements? If I split this into two parts, I'll be having hydrogen, which is one element, and carbon, which is the other element. So it means there are two elements that makes up hydrocarbon, hydrogen and carbon only. So it means that you don't have any additional elements to them, just hydrogen and carbon. So if I write something like this and I say CH4, this is an hydrocarbon. Why? Because it's strictly made up of carbon and hydrogen. But the moment I write CH3 and COOH, this is no longer hydrocarbon, because of the presence of oxygen. So know this, that whenever a compound is strictly made up of carbon and hydrogen, it is said to be called hydrocarbons. Alright? Now, all hydrocarbons are organic compounds. In the world of chemistry, we have the organic and the inorganic. Now, looking at the organic world of chemistry, you have the center focus to be on hydrocarbons, because all hydrocarbons are organic compounds without the exemption. So it's only some non-hydrocarbons that you can refer to as organic compounds, while some of them are inorganic. All hydrocarbons, they are strictly organic compounds. Alright? So now there are divisions of these hydrocarbons, and I would want to give you the different parts, what constitutes hydrocarbons in terms of its division. For hydrocarbons, they can be divided into two parts or two kinds. Now we have the aliphatic hydrocarbons and the aromatic hydrocarbons. Aliphatic and aromatic hydrocarbons. For the aliphatic hydrocarbons, they are regarded as open chain hydrocarbons. Open chain. Then while for the aromatic, they are referred to as closed chain hydrocarbons. I will explain all this. But when you're looking at the aliphatic, you can further split the aliphatic into two parts. We have the acyclic hydrocarbons, and then we have the cyclic hydrocarbons that falls under the aliphatic. So the cyclic, they are also known as alicyclic hydrocarbons. Alright? Now for the acyclic, you can further split this into three parts. That now gives us the organic chemistry, one compounds, talking about the alkanes, and the alkynes. So these are what makes up the acyclic. alkanes, alkenes, and alkynes. Now these ones, they are also called paraffins, that's for the alkanes. Then while the alkenes, they are also called olefins. Then while the alkynes, they are also called acetylenes. Alright? So these are what makes up the acyclic. Then looking at the cyclic, you have the cycloalkanes. And classical examples include, we have cyclopropane. When we start with the series of organic chemistry in this channel, I'll explain quite a number of things with regards to this. Then for the aromatic, the parent compound that you have here is benzene, and then compounds of benzene, you can also find them there too. Because when I say compounds of benzene, I'm referring to derivatives of benzene. And what are some of the derivatives of benzene? We'll talk about phenol, methylbenzene, as toluene. We'll talk about quite a number of things. Some compounds associated with benzene, meaning that they are compounds that are formed by the presence of benzene ring. Alright? So when we say benzene ring, we are simply referring to a ring like this. When you see this kind of structure, just know that this is benzene ring. It's benzene ring, alright? That's benzene ring. And that's the reason why you see that they are cyclic. They are also cyclic too. Just like under the aliphatic, we have cyclic compounds. Under aromatic, I can see quite a number of them, or if not all of them, they are also cyclic. Because if you look at the ring of benzene, you see that it's actually cyclic. Now, when we say cyclic in the world of organic chemistry, please take note of this. That cyclic does not necessarily mean round, something like this. What cyclic means in the world of organic chemistry is that you have carbon atoms at the edges with an enclosed space, something like this. Now, if I want to call the name of this compound, I don't want to represent the hydrogens that should be surrounding the carbons or attached to the carbons. But looking at this kind of compound, you have an enclosed space within, and carbon atoms are found at the edges. So in this case, you call this kind of compound cyclopropane. When we start with the world of organic chemistry, I will explain all this, alright? So looking at hydrocarbons, you see the chain of hydrocarbons, two parts, aliphatic, aromatic, acyclic, and cyclic. Then under acyclic, alkanes, alkenes, and alkynes. And like I said, all hydrocarbons are organic compounds. Then the question is, what are the sources of hydrocarbons? Where can we obtain hydrocarbons from? A question was once asked in past JAM, and then he said that which of the following is the main source of hydrocarbon? Though we have three sources that are considered as the standard sources of hydrocarbons, but among these three sources, there is one that is considered as the main source of hydrocarbon. Now, what are the three sources of hydrocarbon? I'm going to list them now. The sources of hydrocarbons include one, we have crude oil. Then two, we have natural gas, and three, we have coal. All right. So these are the three main sources, but there is one that is considered as the main. That one is like the head. So among these three, there is one considered to be the non-negotiable source of hydrocarbon, and that happens to be crude oil. All right. So crude oil is the main source of hydrocarbons. All right. And please take note of this. In some texts, you might not see crude oil as a source of hydrocarbon. You might see another name being replaced with crude oil, and that name is petroleum. So please take note of this, that petroleum and crude oil, they are same. But petrol and petroleum, they are not the same. Don't say that the short form of petroleum is petrol. No. Petrol is simply a fraction of petroleum or crude oil. Like I said, crude oil and petroleum, they are same. So if you want to obtain other fractions or relevant fractions from crude oil or petroleum, what are you supposed to do? You subject the petroleum or the crude oil to fractional distillation. I'm going to introduce that by showing you the steps of fractional distillation, talking about the fractions that you can obtain when you carry out fractional distillation of crude oil. And I'll also tell you some certain stuffs with regards to crude oil and the applications of crude oil as well. All right, and also how it plays a vital role in our society today, and not only that, even in our automobiles as well. All right, we are back to the fractional distillation of crude oil. On the board, the image is actually with a fractionating column, because one thing you should know is this, that what is being used to separating petroleum or crude oil into its respective fraction is with the use of a fractionating column. Is that you call it a fractionating column, or you call it a distillation column, whichever one. All right. So this column is used to separate the different components, the different hydrocarbons that makes up the crude oil into their respective fractions. All right. So first thing is this, that the crude oil is placed in a furnace. This is a furnace, in a furnace, and preheated to a temperature of about 400 degrees Celsius. So this is where you place your crude oil. Now, after placing the crude oil, it passes through and then is heated in this furnace to about 400 degrees Celsius, which is very high temperature. And then the gases will now be released into the fractionating tower or fractionating column. This is the fractionating tower or fractionating column or fractionation column, whichever one. All right. So they will now be separated into their different components based on differences in their boiling points. Now, starting with this part, you'll be having the release of petroleum gases at temperature below 40 degrees Celsius. While this part, you'll be having petrol temperature between 40 degrees Celsius to 200 degrees Celsius. And for this part, you'll be having kerosene, which is temperature between 200 degrees Celsius to 250 degrees Celsius. And this part, you'll be having gas fuel, or you could say gas oil, and the temperature is between 250 degrees Celsius to 300 degrees Celsius. And then the next part, you'll be having your diesel fuel. This diesel fuel is temperature between 300 degrees Celsius to 350 degrees Celsius. While this one is lubricating oil, which is temperature between 350 degrees Celsius, to 500 degrees Celsius. All right. So you just need to take cognizance of all these. All right. Now, these are based on differences in their boiling point. There was a video lesson I made. I think if you check my previous videos, I made the separation techniques for mixtures, and one of which is actually the fractional distillation, where I said that it involves you separating crude oil or petroleum into their respective components, fractions, and then it's based on differences. The standard is based on differences in their boiling point, and which I said that they have a close difference in their boiling point. All right, but there are still some other things or some other factors that you can use to distinguish them. And what are some of these factors? You can consider odor, you can consider color, you can consider texture, you can consider molecular weight, and as well as you can consider the burning, degree of burning or ignition. All right, degree of burning or ignition. These are other factors that can still be used to distinguishing the fractions, and of which are generally those fractions with higher boiling points. They would certainly be having higher molecular mass. They will also be having low volatility. That's when we say volatility, it means ability to transform or change rapidly into gas. And then they are usually darker in color. And in terms of their degree of burning, they have low ignition or burning process. They are very difficult to burn. All right, very, very difficult to burn. So that's just the fractions that you can get from crude oil. But there is a very important fact that needs to be considered. And what is this fact? Now, when we talk about quality of petrol, now you know that our moving automobiles, they make use of petrol as their main fuel. And some petrol leads to the knocking of engine. That's why sometimes when you see automobiles moving and then you'll be hearing sound, this kind of knocking sound in the engine, that's as a result of poor quality of petrol. And there's a particular grade or number system that is being used to measure the quality of petrol. And that grade or number system is called the octane number. Now you see this octane number, when it is rated 0, it means that the petrol is of low quality. So you are going to be having a low quality petrol when it is 0, when the octane number of a particular petrol is 0. But when it is 100, it is of high quality. So 100 indicates high quality petrol. Alright, take note of this, it's very, very important. High quality petrol, octane number 100, low quality petrol, octane number 0. And generally, straight chain hydrocarbons, meaning talking about a link like this, carbon to carbon to carbon to carbon, without any form of branches, they are actually a kind of indication in petrol that of which that petrol is actually of low quality. What it means is that when a petrol is made of straight chain hydrocarbons, it implies that such petrol is of low quality. But when there is increase in branches of a particular petrol in terms of the chain, then of course it implies that such petrol is of high quality. Meaning, when you have branches in or as the hydrocarbons present in the petrol, it implies the petrol is of high quality. So increasing the number of branches in a given petrol tends to increase the quality of the petrol. And mind you, lastly, you have to take cognizance of this, that heptane is known with an octane number of 0, while 2,2,4-trimethylpentane is known with an octane number of 100. Please take note of this, that heptane, in some terms they will say N-heptane. N stands for normal, so normal heptane. So heptane is with an octane number of 0, because if you want to draw the chain of heptane, the word hep stands for 7 carbons, so you are going to be having a straight chain, something like this. So this is actually 7. So it implies that the petrol is of low quality, and it has been known that heptane has an octane number of 0. Don't forget this. And then while 2,2,4-trimethylpentane has an octane number of 100. Alright? So take note of that. Why? Because if you look at the structure of 2,2,4-trimethylpentane, you ought to know that it has branches, and the branches will be coming from the group attached to the main parent, which is pentane. How many groups? You are having just a single group, which is methyl, and then you have 3 of them to be forming the branches. So when we get to the organic chemistry in detail, then I'll simply explain how you can carry out the impact nomenclature of structures. Alright? So with this, I just want you to go through this video over and over again. Take the main points. What are the main points? In summary, that hydrocarbons are compounds that are made up of carbon and hydrogen only, and all hydrocarbons are organic compounds. The chain, don't forget, aliphatic aromatic, aliphatic open chain, aromatic closed chain. Aliphatic is divided into acyclic and cyclic. Under the acyclic, we now have 3 divisions, which are the alkanes, and the alkynes. Under the cyclic, we have cycloalkanes. We could also have cycloalkenes as well. So, like I explained, cyclic compound does not necessarily mean round. It means an enclosed space with carbon atoms at the edges. And then to the aromatic world, we talk about main parent compound there, which is benzene, and then its derivatives, compounds that are formed by benzene. Also take note of the sources of hydrocarbons. There are 3 main sources, don't forget. We have the crude oil, which is also known as petroleum. We have natural gas, and then we also have coal. But among these 3, there's one considered as the main source of hydrocarbons, which happens to be crude oil. Like I've explained initially, that crude oil can carry out fractional distillation, can undergo fractional distillation to obtain relevant fractions of it. And it is due to differences in boiling point and some other differences as well, but the main still remains differences in boiling point. Then I also went on to saying that petrol could be of low quality or could be of high quality. High quality petrol simply means that the octane number is high, while low quality petrol simply means that the octane number is low. So you can actually determine the octane number of a certain petrol when, for example, let's say you are giving 50% of a certain petrol is heptane and 50% is 2,2,4 trimethylpentane. Okay, now if you are asked what is the octane number when you are having 50% going to the heptane and 50% to the 2,2,4 trimethylpentane, and then you have it to be as mixture in a given petrol. Of course, the octane number will be 50 because you don't take the other 50 of the heptane to be part of it. What you take is the 50 of the 2,2,4 trimethylpentane. So for example, let's say given the percentage of 2,2,4 trimethylpentane in a petrol to be 60, and then you are giving the heptane to be 40, and then you are told to calculate the octane number, it is 60. So what actually determines the octane number? It is the percentage of the 2,2,4 trimethylpentane. Don't forget that 2,2,4 trimethylpentane is actually the percentage of it is actually what determines the octane number. Do you understand? So what it means is this: if I have 70% of 2,2,4 trimethylpentane and I have 30% of heptane as a mixture that makes up petrol, just know that we are going with the 70. So the octane number is very easy to determine. It becomes 70. So it's that easy. Alright? So thanks for watching, and don't forget to stay glued to this channel because I'm going to be revealing quite a number of things. You can let your friends to be aware of it as well because they will benefit much too. Thanks for watching and stay tuned.